All right, so we've talked about the easy type. Okay, the easy type of question is when you're just given the two matrices and you're told to determine whether or not they're inverses. It's just a multiplication problem with the target. That's it. So very little is different other than multiply these together and check to see that my answer matches to what they told me it was supposed to match to. Where it starts to get a little bit more complicated is if we are given a matrix and now it's our task to find the inverse. And that's when all of a sudden we sort of up the difficulty, so to speak. Okay? So you remember a few chapters back, you had something like this, y equals, 4x squared minus 7. You remember how we found the inverse to this?
You set it like the y to the x.
So we would rewrite it as this, wouldn't we? And then we'd go about solving for the y, wouldn't we? You guys remember doing that back in chapter 1 and chapter 2? Okay, good. So again, we know how to algebraically find an inverse. So remember, it's going to be a little bit different, obviously, with matrices, obviously, because we don't have an equation or anything like that necessarily. But there's going to be some switching involved. Okay, there's going to be some switching involved. So we say that if A is a square matrix of order n by n. So remember, if you're ever trying to calculate or find an inverse, first thing to check is, do I have a square matrix? Because if I don't have a square matrix, we're wasting our time. It's never going to work out. All right, so our task is going to be first and foremost to set up an augmented matrix. We're going to augment matrix A with the same order identity. So if we're going to go, again, I'm going to go extremely basic here. We have 1, 2, 3, 4. If that's matrix A, 1, 2, 3, 4. It says to augment with the identity. So we're going to create 1, 2, 3, 4 augmented with the identity 1, 0, 0. So that's how we start. We're going to set the problem up this way. From there, it says that we're going to convert the left side to reduced row echelon form. So that means over here, the left side, we're trying to get to reduced row echelon form. What does that mean again? Positive ones on the diagonal, zeros everywhere else. Kind of what the right side currently looks like. Yeah. So as we're adjusting the left side, aren't the numbers on the right side also going to be moving and adjusting and changing? Yeah. So what we're saying is that we want to go to work here, so to speak, and we're going to do our row operations until we get 1, 0, 0, 1. And now at this time, we're going to have different numbers on the right side. Once we're here, where we have reduced row echelon form on the left, this stuff on the right, that's my inverse. Does that make sense? So again, so much of this is in the setup. Take your original matrix, augment with the identity, then do your row operations to turn the left side into reduced row echelon form. What you're left with remaining on the right side, there's your identity. All right, now we just drew it up here. Obviously, we haven't done the problem yet. We just drew it up for a 2x2. Could we do this for a 3x3 or 4x4 or whatever else size we have? Sure, we could. The process is identical, exactly the same. All right? How do we feel about the process? I know we haven't done it yet, but does it kind of make sense before we dive into this next one? All right, so let's try it. So here we have matrix A. First step, it says, is to take matrix A, 1, -2, -1, 3, and augment with the identity, 1, 0, 0, 1. All right, is everybody with me so far? Again, crucial first step that we get this set up accurate. Now from here, different options as far as where we go. I'm looking at this positively, like, all right, we wanted row 1, column 1 to be a 1. We have it. So my next target, working down that first column, is that -1. What do I want that to be, please? That has to be a 0. So my first row is going to stay 1, -2, 1, 0. My second row, though, what do we think? How can I turn a -1 into a 0? So we're thinking that we're going to add all of row 1 plus all of row 2. All right, so 1 plus -1, 0. -2 plus 3, 1. There's a break. 1 plus 0, 1. 0 plus 1, 1. All right, that was a break. Row 2, column 2, we weren't really targeting that, but it became a 1 anyway. So now my last remaining target, that -2 in row 1, column 2, what do I need that to become, please? I need to make that into a 0. So my second row is going to stay put, but how could I use the second row to create a cancellation in that row 1, column 2 place? So what was that? 2? Did I hear? 2 times row 2 plus row 1. All right, so that means that I have to double row 2 and then add it up to row 1. All right, so 2 times 0 is 0, plus 1 is 1. 2 times 2 is 2, plus negative 2 is 0. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2, plus 0, 2. All right, have we done it? Is my left side currently in reduced row echelon form? It is. We should be very happy about that because reduced row echelon form here tells us that we just found our inverse there. So to answer the question, what's the inverse? A inverse will be 3, 2, 1. How are we feeling here, guys? Pretty great? All right, now, one of the nice things about math that very seldom do people at this level actually take advantage of, but can we check our work to be certain that we did this properly? How could we do it? A inverse times A, what should I get? We should get the identity, okay? All right, now, question. Could we do the exact same thing with the bigger 3 by 3? Now, is it going to be any harder to do this? It's a lot longer, but it's not going to be any harder. It's the same process. So the setup here is going to be 1, 1, 1, 3, 5, 4, 0, negative 1, 0. We're going to augment this with the identity. Like that. And then we're going to go about tackling one piece at a time. I'm going to skip over this one just for the time being because I really want to show you that there's actually a shortcut to that previous problem. Okay? So, there's good news and bad news. Whoa. Wrong thing. All right, good news and bad news about using formulas. The good news is that they exist because they're kind of like shortcuts, right? The bad news is that if you're going to use a formula, you have to remember a formula. So I understand that there are some of us that are probably really good at memorizing formulas and others, that's not exactly our strong suit. So never will you be told that you have to use this formula. This formula is totally and completely optional, but I would say that in the last 7 years of teaching pre-calculus, probably 95% or more of the students have said, yeah, I want to use the formula. Okay? It's your call, it's your decision. You don't have to use the formula, but I'm going to use the formula more often than not because I believe that it is a little bit easier. Okay? It's a little bit more direct. So here's how it works. For starters, the catch is, unfortunately, that the formula only works on 2 by 2 matrices. It doesn't work on the 3 by 3s. If you have a 3 by 3 and you have to find the inverse, we're going to have to go through the lengthy process of row operations and all that. Sorry in advance, but I mean that's the reality of it. So if we have a 2 by 2 matrix that's of this A, B, C, D format, we also have to say, and also AD minus BC does not equal 0. We'll explain why here in a minute. Okay, we're saying that our little formula is going to claim that A inverse is really going to be equal to 1 over AD minus BC. This is a scalar that we're creating here, times, you can see that we've adjusted. It's not ABCD anymore, but there's actually less that's changed than what might originally meet the eye. All that's happening from the original to this new one is that A and D, they traded places. What happened to B and C? They just became their opposites. So we say that A and B switch, B and C are negated. Okay? So that just means that they change signs. If it was positive, it becomes negative. If it was negative, it becomes positive. All right? So once again, going back to this idea, 1 over AD minus BC, a term that you may remember from Algebra 2 last year, maybe, is determinant. Okay? Again, when you talked about matrices, you probably found the determinant. The way that you did that was that you multiplied diagonally going down, then you multiplied diagonally going up, and you found the difference. That's the determinant on the 2 by 2 matrix. So when we say 1 over this is the determinant, are we seeing now with this setup why AD minus BC can't equal 0? Because if we set this up as 1 over 0, we're asking for trouble, right? So we have to stay away from that. If the determinant's 0, then this formula doesn't work. All right, so as we look at this, we have to create the scalar, and then we're going to scale it through the adjusted 2 by 2 matrix. All right, and then we introduce that term determinant down here. We'll talk about that a heck of a lot more in section 8.4. But let's go ahead and try out this formula once here. So, as we can see, 3, negative 1, negative 2, 2. We're going to start off and say that A inverse is equal to 1 over, all right. When I multiply going down here, 3 times 2, that's going to be 6, minus multiply diagonally going up. Negative 2 times negative 1 is 2. All right, we also need to adjust the 2 by 2 matrix. So what did it say that we need to do? Or we could look up there. places. So 2's here, 3's there. What happens to B and C? They change signs. So the opposite of negative 1 is 1. The opposite of negative 2 is 2. All right, so as we clean this up really quickly, what is 6 minus 2? So my scalar is 1/4, 2, 1, 2, 3. So now when we scale 1/4 through with your help, sorry guys, give me 1 second here. Isn't that going to be 1/2, 1/4, 1/2, 3/4? All right, now this is our inverse. Could we have done this using row operations? Absolutely yes. But again, looking at this many fractions, you think that might have been a pain in the butt? Okay, so this is going to be our better option. Okay, so guys, tomorrow we're going to pick up. We're going to circle back. I'm going to put a video together for this one. Again, the 3x3. I would encourage you to check that out. But guys, we should be able to do everything on the assignment with the exception of solving the equations. That's what we're going to talk about tomorrow. If I were you, I would do all of that until what you get to. All right, have a good night.